The law of 7. The number of fundamental laws that govern all processes both in the world and in man is very small. Different numerical combinations of a few elementary forces create all the seeming variety of phenomena. Hence, in order to understand the mechanics of the universe, it is necessary to resolve complex phenomena into these elementary forces. The first fundamental law of the universe is the law of 3 forces, or 3 principles, as it is often called, the law of 3. According to this law, every action, every phenomenon in all worlds without exception is the result of a simultaneous action of 3 forces, the positive, the negative and the neutralizing. Of this we have already spoken, and in future we will return to this law with every line of new study. The next fundamental law of the universe is the law of 7, or the law of octaves. In order to understand the meaning of this law, it is necessary to regard the universe as consisting of vibrations. These vibrations proceed in all kinds, aspects and densities of the matter that constitutes the universe, from the finest to the coarsest. They issue from various sources and proceed in various directions, crossing one another, colliding, strengthening, weakening or even arresting one another and so on. In this regard, according to the usual views accepted by Western science, vibrations are continuous. This means that vibrations are usually regarded as proceeding uninterruptedly, ascending or descending, as long as there continues to act the force of the original impulse that caused the vibration, and which overcomes the resistance of the medium in which the vibrations proceed. When the force of the impulse becomes exhausted and the resistance of the medium gains the upper hand, then the vibrations naturally die down and stop. However, until this moment is reached, that is until the beginning of the natural weakening, the vibrations develop uniformly and gradually. In the absence of any resistance, they could even become endless. One of the fundamental propositions of our physics is the continuity of vibrations. Although this has never been precisely formulated, it has nonetheless never been opposed. In certain of the newer theories, this proposition is beginning to be shaken. However, physics is still very far from a correct view on the nature of vibrations, or what corresponds to our concept of vibrations in the real world. In this area, the view of ancient knowledge is opposed to that of contemporary science, because at the base of the understanding of vibrations, ancient knowledge places the principle of the discontinuity of vibrations. The principle of the discontinuity of vibrations means the definite and necessary characteristic of all vibrations in nature, whether ascending or descending, to develop not uniformly, but with periodic accelerations and retardations. This principle can be formulated more precisely if we say that the force of the original impulse in vibrations does not act uniformly, but as it were, becomes alternately stronger and weaker. The force of the impulse acts without changing its nature, and vibrations develop in a regular way only for a certain time, which is determined by the nature of the impulse, the medium, the conditions and so on. At a particular point, however, a certain change takes place and the vibrations, so to speak, cease to obey the force of impulse, and for a short time actually slow down, changing their nature or direction. For example, ascending vibrations, at a certain point begin to ascend more slowly, or descending vibrations begin to descend more slowly. After this temporary retardation, both in ascending and descending, the vibrations again enter the former channel and for a certain time, ascend or descend uniformly up to a certain moment, when a check in their development again takes place. In this context, it is important to note that the periods of uniform action of momentum are not equal, and the moments of retardation of vibration are not symmetrical. One period is shorter and the other is longer. In order to determine these moments of retardation, or checks in the ascent and descent of vibrations, the lines of development of vibrations are divided into periods, corresponding to the doubling or the halving of the number of vibrations in a given space of time. Imagine then a line of increasing vibrations, and take them at the moment when they are vibrating at the frequency rate of 1000 per second. After a certain period, the number of vibrations is doubled and it reaches 2000. It has been established that in this interval of vibrations, between a given number of vibrations and a number twice as large, that there are 2 places where a retardation in the increase of vibrations takes place. One is near the beginning, but not at the beginning itself, and the other is almost at the end. This can be illustrated approximately in the manner illustrated. The laws that govern the retardation or the deflection of vibrations from their primary direction were known to ancient science. These laws were then incorporated into a particular formula or diagram that has been preserved up to our times. In this formula, the period in which vibrations are doubled was divided into 8 unequal steps, corresponding to the rate of increase in the vibrations. The 8th step repeats the first step with double the number of vibrations. This period of the doubling of the vibrations, or the line of the development of vibrations, between a given number of vibrations and double that number, is called an octave, which is to say, composed of 8. The principle of dividing into 8 unequal parts, the period in which vibrations are doubled, is based upon the observation of the non-uniform increase of vibrations in the entire octave, where separate steps of the octave show acceleration and retardation at different moments of its development. In the guise of this formula, ideas of the octave have been handed down from teacher to pupil, from one school to another. In very remote times, one of these schools found that it was possible to apply this formula to music, and in this way was obtained the 7-tone musical scale that was known in distant antiquity, then forgotten, and once again rediscovered or found. The 7-tone scale is the formula of a cosmic law that was worked out by ancient schools and applied to music. At the same time, however, if we study the manifestations of the law of octaves in vibrations of other kinds, we can see that the laws are everywhere the same, and that light, heat, chemical, magnetic and other vibrations are all subject to the same laws as sound vibrations. For example, the light scale is known to physics. In chemistry, the periodic system of elements is also without doubt closely connected with the principle of octaves, although this connection may not be fully comprehended by science today. A study of the structure of the 7-tone musical scale gives a good foundation for understanding the cosmic law of octaves. Once again then, take the ascending octave, that is the octave in which the frequency of vibrations increases. Then let us suppose that this octave begins with 1000 vibrations per second, and designate these 1000 vibrations by the note, do. Vibrations are growing, that is their frequency is increasing, and at the point where they reach 2000 vibrations per second there will be a second do, that is the do of the next octave. The period between one do and the next, an octave, is divided into 7 unequal parts, because the frequency of vibrations does not increase uniformly. The ratio of the pitch of the notes, of the frequency of vibrations will be as illustrated. The difference in the acceleration or increase in the notes or the difference in tone will be as shown. The difference in the notes or the differences in the pitch of the notes are called intervals, and we see that there are 3 kinds of intervals in the octave, 9/8, 10/9 and 16/15, which in whole numbers correspond to 405, 400 and 384. The smallest interval 16/15 occurs between mi and fa, and between ti and do. These are precisely the places of retardation in the octave. With regard to the musical 7-tone scale, it is generally considered theoretically that there are 2 semitones between each 2 notes, with the exception of the intervals mi fa and ti do, which have only 1 semitone, and where 1 semitone is regarded as being left out. In this manner 20 notes are obtained, 8 of which are fundamental, do re mi fa sol la ti do, and 12 intermediate, 2 between each of the following 2 notes, do re mi, fa sol la, and la ti. Then 1 between each of the following 2 notes, mi fa and ti do. However, in practice, namely in music, instead of 12 intermediate semitones, only 5 are taken, that is 1 semitone between do re mi, fa sol la and la ti. Between mi and fa and between ti and do the semitone is not taken at all. In this way the structure of the musical 7-tone scale gives a scheme of the cosmic law of intervals, or absent semitones. In this respect, when octaves are spoken of in a cosmic or a mechanical sense, only those intervals between mi fa and ti do are called intervals. If we grasp its full meaning, the law of octaves gives an entirely new explanation to the whole of life, of the progress and development of phenomena on all planes of the universe observable by us. This law explains why there are no straight lines in nature, and why we can neither think nor do, why everything in us is thought, why everything happens with us, and usually in a way that is opposed to what we want or expect. All of this is a clear and direct effect of the intervals or retardations, in the development of vibrations. What precisely does happen then at the moment of the retardation of vibrations? A deviation from the original direction takes place. The octave begins in the direction shown by the arrow. However, a deviation takes place between mi and fa, then the line begun at do changes its direction through fa, so, la and ti, it descends at an angle to its original direction, shown by the first 3 notes. Then between ti and do the second interval occurs, a fresh deviation, and a further change of direction. The next octave gives an even more marked deviation, the one following that a deviation that is more marked still, so that the line of octaves may at last completely turn around and proceed in a direction opposite to the original. In developing further, the line of octaves or the line of development of vibrations may return to the original direction and, in other words, make a complete circle. The law shows why straight lines never occur in our activities, and why, having begun to do one thing, we in fact do something entirely different, often the opposite of the first. Although we do not notice this, of course, and continue to think that we are doing the same thing that we set out to do, all of this and many other things can be explained with the help of the law of octaves, together with an understanding of the role and significance of intervals that cause the line of the development of force constantly to change, to go in a broken line, to turn around, and to become its own opposite, and so on. such a course of things, and the change in their direction can be observed in everything. After a certain period of energetic activity or strong emotion, a right understanding, a reaction comes. Work becomes tedious and tiring, moments of fatigue and indifference enter into feeling, and instead of right thinking, a search for compromises begins, suppression and the evasion of difficult problems. However, the line continues to develop, though now not in the same direction as it was at the beginning. Work becomes mechanical, feeling becomes weaker and weaker, descending to the level of the common events of the day, and thought becomes dogmatic or literal. Everything proceeds in this way for a certain time, and then once again, there is a reaction, again a stop and again a deviation. The development of the force may continue, but the work that was begun with such zeal and enthusiasm has become obligatory and a useless formality. A number of entirely foreign elements have entered into feeling, considering, vexation, irritation and hostility. Thought goes around in a circle, repeating what was known before, and the way out that had been found becomes more and more elusive. The same thing happens in all spheres of human activity. In literature, science, art, philosophy and religion, in individual and above all in social and in political life. We can observe how the line of the development of forces deviates from its original direction, and goes after a certain time, in a diametrically opposite direction, still preserving its former name. Perhaps the most interesting examples of such change of direction in the line of development of forces can be found in the history of religion, particularly in the history of Christianity if it is studied dispassionately. Consider how many turns the line of development of forces must have taken to come from a gospel-preaching love, to arrive at the barbarism of the Inquisition. Or to go from the ascetics of the early centuries studying esoteric Christianity, to the scholastics who calculated how many angels could be placed on the point of a needle.